In this section, we'll connect the ISO management system model to real AI governance work. As a lead implementer, your role is to turn clauses into coordinated practices across scope, assets, architecture, risk, controls, audits, and certification readiness. We've established why ISO IEC 4220 and Throw1 exists, to support trustworthy AI governance through an AI management system. Now we move from purpose to structure. You'll see how ISO clauses translate into processes, policies, evidence, and implementation decisions that architects need before defining scope, inventories, and controls. ISO IEC 4021 is best understood as an operating model for responsible AI, not a binder of compliance evidence. It starts with context, policy, objectives, and accountability. From there, architects help translate risks into controls, resources, and operational practices. Those practices are monitored, measured, reviewed, and improved. The main point is integration. The aims should influence design choices, delivery workflows, and business decisions. For AI architects, the standard becomes both a governance framework and a design constraint across the lifecycle. Clauses 4 through 10 provide the structure for that management system. Clause 4 defines the environment, stakeholders, obligations, risks, and boundaries. Clause 5 establishes leadership, accountability, and policy direction. Clauses 6 through 8 turn intent into action through planning, resources, competence, communication, documentation, and operational control. Then clauses 9 and 10 close the loop. The organization measures performance, audits the system, reviews results, and improves what is not working. Together, these clauses create a governance cycle. Understand the context, set direction, execute consistently, evaluate evidence, and keep improving. Clause 4 anchors aims governance in reality. Before defining controls, the organization must understand the forces that shape its AI risk: regulations, market expectations, ethical concerns, technology change, and internal capability. It also needs to identify who has a stake in the system, from regulators and customers to users, data teams, model owners, and security teams. For architects, the key outcome is a defensible boundary. Which platforms, AI systems, teams, and processes are inside the AIMs? Which are outside, and why? Strong scope decisions begin with clear context analysis. Clause 5 makes AI governance owned, not assumed. Top management must set the AI policy, define accountability, and make responsibilities clear across governance, architecture, security, legal, data, risk, and operations. The key idea is integration. The aims should shape real business and technical decisions. Architects support this by turning leadership intent into standards teams can actually follow. Clause 6 turns uncertainty into a planning discipline. Start by identifying AI risks and opportunities in context: intended use, foreseeable misuse, affected stakeholders, and lifecycle stage. Then evaluate impact, including bias, drift, data quality, security, and human consequences. From there, choose treatments and translate them into concrete controls, operating procedures, and accountable owners. Objectives should be measurable, such as assessment coverage, control maturity, audit readiness, or incident response time. Change also needs to be managed deliberately, because new data, models, prompts, integrations, or deployment settings can alter the risk profile. Clause 7 asks a practical question. Do people have what they need to govern AI consistently? That includes tools, infrastructure, funding, and access to expertise. It also includes defined competence for each role, from model owners and data engineers to risk assessors and operators. People need to understand the policy, know when to escalate, and communicate decisions clearly. Documentation must also be controlled. Policies, procedures, risk records, evidence, and audit artifacts should be current, findable, and repeatable. Clause 8 is where the aims becomes real in day-to-day work. Plans, policies, and risk treatments must be embedded into each lifecycle step, from design and data preparation through validation, deployment, monitoring, and retirement. The key idea is controlled execution. Teams define what must be checked, who approves movement to the next stage, how exceptions are handled, and what evidence is created. Supplier components need the same discipline through evaluation, contracts, and integration controls. For architects, the goal is simple. Every operational decision should be governed, traceable, and reviewable. Clause 9 turns the aims from a documented system into a measured one. The question is no longer, do we have processes? It is, are they working? That means selecting metrics for governance activities, checking conformity through internal audits, and bringing results to management review. Leaders should see risks, incidents, audit findings, overdue actions, and opportunities in one evidence-based view. Architects contribute architecture review records, control implementation status, model monitoring results, and technical risk assessments. Good evidence makes governance visible, auditable, and improvable. Clause 10 is where the AI management system learns. A nonconformity might be an audit finding, missing model validation evidence, weak human oversight, or a control that failed in practice. The goal is not to patch the symptom and move on. Detect the issue, analyze the root cause, define corrective action, implement it, and verify that it worked. Then feed the lesson back into standards, patterns, reference architectures, and delivery guardrails. This loop keeps the aims aligned with new use cases, changing model behavior, and emerging regulatory expectations. The lead implementer coordinates the work that turns aims requirements into an operating management system. It starts with scope and stakeholder alignment, then moves into governance structure and the implementation roadmap. As AI use cases are assessed, the lead implementer connects risks to appropriate controls, treatment actions, owners, and evidence. Just as important, they keep documentation, audit readiness, and management review preparation moving. This role is not isolated. It brings executives, architects, legal, security, data, product, and operations teams into one coordinated lifecycle. The lead implementer mindset is about making ISO IEC 42001 part of how AI work actually happens. Requirements should enter at design, not after deployment. Risk reviews should become decision gates, with approvals based on evidence and accountability. Controls should support continuous monitoring, so issues are detected, escalated, and corrected while the system is operating. Audit evidence should be created naturally through normal workflows. That is the shift. Not producing documents for certification, but building a management system that improves decisions, reduces AI risk, and keeps improving over time. ISO IEC 42001 works best when it is not treated as a separate compliance track. It should become part of how architecture decisions are already made. Review boards can challenge AI designs against scope, risk, controls, and policy. Design authorities can approve reusable patterns, model services, and human oversight approaches. Technical standards turn requirements into concrete expectations for data, logging, security, validation, and monitoring. Delivery methods then add checkpoints into Agile, DevSecOps, MLOps, and change control. The result is governance that produces evidence as work happens. To wrap up, ISO IEC 42001 becomes practical when clauses 4 through 10 operate as one management system, not as separate requirements. The lead implementer connects stakeholders, risks, controls, evidence, and governance. Architecture governance then embeds the aims into real AI design decisions. Next, you will define scope, boundaries, and inventory before interpreting annex controls through an architecture lens.